What is the vehicle? A vehicle is a machine or device designed to transport people, goods, or materials from one place to another. Vehicles are typically used for transportation purposes and come in various forms such as cars, trucks, motorcycles, bicycles, boats, airplanes, trains, and buses. Vehicles generally have a means of propulsion, which can be powered by various sources such as internal combustion engines using gasoline or diesel, electric motors, or even human power in the case of bicycles. The design and capabilities of vehicles can vary greatly depending on their intended use, such as personal transportation, commercial transportation, recreational activities, or industrial applications. Vehicles typically have wheels or tracks that allow them to move over land, while others are specifically designed for travel on water or in the air. They often have a seating or cargo area to accommodate passengers or goods, as well as various control mechanisms to steer, accelerate, and brake the vehicle. The development of vehicles has significantly impacted society, enabling greater mobility, trade, and exploration. They have become an integral part of modern life, providing transportation options for individuals and facilitating the movement of goods and services across vast distances. Here are some additional points about vehicles. 1. Classification: vehicles can be categorized into different types based on their purpose, design, and mode of operation. Common classifications include passenger vehicles (G), cars, buses, commercial vehicles (G), trucks, delivery vans, recreational vehicles (G), motorcycles, RVs, and specialized vehicles (G), construction equipment, emergency vehicles. 2. Automotive industry. The automotive industry plays a significant role in the design, manufacturing, and distribution of vehicles. Major automakers around the world produce millions of vehicles each year, employing advanced technologies and engineering expertise to enhance performance, safety, and efficiency. 3. Fuel sources. Vehicles can be powered by various fuel sources. Internal combustion engines, which burn fuel within the engine to generate power, have traditionally been used in most vehicles. However, there is a growing shift towards alternative fuels and electric propulsion. Hybrid vehicles combine internal combustion engines with electric motors, while fully electric vehicles rely solely on electric power stored in batteries. 4. Safety. Vehicle safety has been a major focus in the automotive industry. Manufacturers incorporate numerous safety features such as seatbelts, airbags, anti-lock braking systems (ABS), stability control, and advanced driver assistance systems (ADAS) to enhance occupant protection and reduce the risk of accidents. 5. Environmental impact. The environmental impact of vehicles, particularly those powered by fossil fuels, has raised concerns about air pollution and carbon emissions. As a result, there is increasing interest in developing and promoting electric vehicles (EVs) and other low-emission alternatives to reduce greenhouse gas emissions and dependence on fossil fuels. 6. Autonomous vehicles. The emergence of autonomous or self-driving vehicles represents a significant advancement in vehicle technology. Autonomous vehicles use a combination of sensors, cameras, and artificial intelligence to navigate and operate without human intervention. While still in the development and testing phase, autonomous vehicles have the potential to revolutionize transportation by improving safety, efficiency, and accessibility. 7. Future trends. The future of vehicles is expected to involve further advancements in electric and autonomous technologies. This includes the development of more efficient batteries, the expansion of charging infrastructure for electric vehicles, and the continued refinement of self-driving capabilities. Additionally, the concept of shared mobility, where people can access vehicles on demand through services like ride-sharing and car-sharing, is gaining popularity as a sustainable transportation solution. These points provide a glimpse into the diverse aspects and ongoing developments in the world of vehicles. The automotive industry continues to evolve, driven by technological advancements, environmental considerations, and changing societal needs. Vehicles can be broadly classified into several types based on their design, purpose, and mode of operation. Here are some common types of vehicles. 1. Cars. Cars, also known as automobiles or passenger vehicles, are designed primarily for the transportation of people. They typically have 4 wheels, seating capacity for a few passengers, and are powered by internal combustion engines or electric motors. Cars come in various sizes and styles, including sedans, hatchbacks, SUVs, coupes, and convertibles. 2. Trucks. Trucks are vehicles designed for carrying goods or materials. They have a larger cargo area compared to cars and are often used for commercial purposes, such as transportation, delivery, and hauling. Trucks can vary in size, from small pickup trucks to large semi-trailer trucks used for long-distance transportation. 3. Motorcycles. Motorcycles are two-wheeled vehicles powered by an engine. They provide a lightweight and agile mode of transportation, typically accommodating 1 or 2 riders. Motorcycles are commonly used for personal transportation, recreation, and sometimes for delivery services in urban areas. 4. Bicycles. Bicycles are human-powered vehicles that have 2 wheels. They are propelled by the rider pedaling and are commonly used for personal transportation, exercise, and recreational purposes. Bicycles come in various types, including road bikes, mountain bikes, hybrid bikes, and electric bikes. 5. Buses. Buses are large vehicles designed to transport a significant number of passengers. They are commonly used for public transportation, school transportation, and long-distance travel. Buses can range from small minibuses to large articulated buses capable of carrying dozens of passengers. 6. Boats. Boats are watercraft designed for travel and transportation on water. They can be powered by engines, sails, or oars, depending on the type of boat. Boats serve various purposes, such as recreational boating, fishing, transportation across bodies of water, and maritime commerce. 7. Airplanes. Airplanes, also known as aircraft or planes, are vehicles designed for air travel. They have wings and are powered by engines that enable them to generate lift and overcome gravity. Airplanes are used for commercial air travel, cargo transportation, military operations, and general aviation. 8. Trains. Trains are vehicles that run on tracks and are used for the transportation of passengers and goods over land. They consist of locomotives that provide the power and a series of connected railcars or carriages. Trains are commonly used for public transportation, long-distance travel, and the shipment of freight. These are just a few examples of the many types of vehicles that exist. Each type serves specific purposes and is designed to meet the requirements of different modes of transportation. The development and ongoing updates of vehicles can be traced back to the early days of transportation. The history of vehicle development can be divided into several key milestones. 1. Invention of the wheel. The discovery of the wheel, believed to have occurred around 3500 BCE, was a crucial development in transportation. It led to the creation of carts and wagons, which were the earliest forms of wheeled vehicles. 2. Industrial Revolution. The Industrial Revolution, which began in the 18th century, brought significant advancements in transportation. Steam power was harnessed to create steam engines, leading to the development of steam-powered locomotives and steamboats. 3. Automobile era. The late 19th and early 20th centuries saw the rise of automobiles. Carl Benz is often credited with inventing the first practical automobile powered by an internal combustion engine in 1886. This marked the beginning of the automobile industry and the subsequent rapid development of cars. 4. Mass production and standardization. In the early 20th century, the introduction of assembly line production methods by Henry Ford and his Model T revolutionized the manufacturing process. Mass production and standardization made cars more affordable and accessible to the general population. 5. Technological advancements. Over the years, vehicles have seen numerous technological advancements. These include improved engine designs, safety features e.g. seat belts, airbags, development of new materials e.g. lightweight alloys, advancements in aerodynamics, and the introduction of electronic systems e.g. fuel injection, anti-lock braking systems. 6. Environmental considerations. In recent decades, concerns about environmental impact and sustainability have driven the development of more fuel-efficient and environmentally friendly vehicles. This has led to advancements in hybrid vehicles, electric vehicles (EVs), and alternative fuel technologies. 7. connectivity, and autonomy. The integration of advanced technologies into vehicles has led to the era of connected and autonomous vehicles. This includes features such as GPS navigation systems, in-car entertainment systems, driver assistance systems, and ongoing research and development in autonomous or self-driving vehicles. It is important to note that vehicle development is an ongoing process, with constant updates and improvements being made by manufacturers and researchers. New technologies, safety regulations, environmental considerations, and changing societal needs continue to drive the evolution of vehicles. The first vehicle, as we understand it today, was not a single invention, but rather a gradual evolution of transportation technology over thousands of years. The exact origins of the first wheeled vehicle are difficult to pinpoint, as early evidence suggests that wheels were used in various forms in different regions of the world. Archaeological evidence suggests that the invention of the wheel occurred around 3500 BCE in Mesopotamia, modern-day Iraq, and the Eurasian steppe. These early wheels were likely used for pottery making and other stationary purposes before being adapted for transportation. The oldest known wheeled vehicles that were used for transportation were discovered in the archaeological site of Sumer in Mesopotamia. These ancient vehicles, known as Mesopotamian chariots, were horse-drawn carts with solid wooden wheels and were used for both transportation and warfare. They date back to around 2500 BCE. It's important to note that before the invention of the wheel, humans used other means of transportation, such as sledges, boats, and animals for carrying loads. However, the wheel revolutionized transportation by providing a more efficient and versatile method of moving goods and people over land. Since the invention of the wheel, the development of vehicles has been a continuous process, with advancements in technology, engineering, and industrialization leading to the wide variety of vehicles we have today. Before the invention of the wheel, humans used various means of transportation to move goods and themselves over land and water. Here are some notable examples. 1. Walking. Walking is the most basic form of human transportation. It relies on the natural ability to move on foot and has been used throughout history for short distance travel. 2. Animal backs. Humans domesticated animals and used them as a means of transportation. Animals such as horses, donkeys, camels, elephants, and reindeer were trained and ridden by humans to carry loads and transport people over long distances. 3. Sleds and sledges. In regions with snowy or icy terrain, sleds or sledges were used for transportation. These vehicles were typically made of wood or animal bones and were pulled over the snow or ice by humans or animals. 4. Boats and canoes. Water transportation played a crucial role in early human civilizations. Boats and canoes made from logs, reeds, or animal skins were used for navigation on rivers, lakes, and coastal areas. They allowed for the transport of goods and people over water. 5. Rafts. Rafts were simple watercraft made from logs or bundled reeds tied together. They were used for short-distance travel on rivers and lakes. 6. Palanquins and litters. Palanquins and litters were types of portable seats or beds carried by a group of individuals. They were often used by nobility or the wealthy for transportation, especially in areas where wheeled vehicles were not yet developed or suitable for the terrain. 7. Skis. In snowy regions, skis were used as a means of transportation. They allowed individuals to glide over snow-covered surfaces, facilitating travel across snowy landscapes. These are just a few examples of the various means of transportation used by humans before the invention of the wheel. Each method was adapted to suit the local environment, available resources, and cultural practices of different civilizations throughout history. The invention of the wheel had a profound impact on transportation methods and marked a significant advancement in human civilization. Here are some key ways in which the wheel revolutionized transportation. 1. Enhanced efficiency. The wheel, when attached to a vehicle, greatly reduced friction and allowed for smoother movement over land. This increased efficiency made it easier to transport goods and people, reducing the physical effort required compared to other means of transportation. 2. Increased load capacity. The use of wheeled vehicles enabled humans to transport heavier loads over longer distances. The distribution of weight across multiple wheels reduced the strain on both the vehicle and the animals or humans pulling it, enabling the transportation of larger and heavier cargo. 3. Greater mobility. Wheeled vehicles provide humans with greater mobility and the ability to travel faster. This allowed for the exploration and colonization of new territories, trade over longer distances, and facilitated the movement of armies during warfare. 4. Expansion of trade and commerce. The invention of the wheel contributed to the growth of trade and commerce as it facilitated the transportation of goods to distant markets. Wheeled vehicles enabled the exchange of goods between communities and civilizations, leading to economic development and cultural exchange. 5. Agricultural advancements. The wheel played a crucial role in agriculture. It allowed for the development of plows and wagons, enabling farmers to cultivate larger areas of land and transport crops more efficiently. This led to increased agricultural productivity and the ability to support larger populations. 6. Technological advancements. The invention of the wheel spurred further technological advancements. It led to the development of more sophisticated axle and bearing systems, improvements in vehicle design, and the creation of new tools and machinery. 7. Cultural and social impact. The wheel had a profound impact on human society and culture. It influenced the design of cities, trade routes, and infrastructure. It also transformed social structures by enabling the movement of people, goods, and ideas, and fostering interaction between different communities. The invention of the wheel marked a significant milestone in human history, revolutionizing transportation and shaping the course of civilization. It laid the foundation for future advancements in vehicle technology and remains a fundamental element of modern transportation systems. The invention of the wheel had a significant impact on warfare and military strategies throughout history. Here are some key ways in which the wheel influenced warfare. 1. Mobility and speed. The use of wheeled vehicles in warfare provided armies with increased mobility and speed on the battlefield. Chariots, for example, allowed for swift movements and quick flanking maneuvers, giving an advantage in both offensive and defensive operations. 2. Transportation of soldiers and supplies. Wheeled vehicles facilitated the transportation of soldiers, weapons, and supplies to and from the battlefield. This enabled armies to project their power over larger territories and sustain military campaigns over longer distances. 3. Increased firepower. The invention of the wheel led to the development of siege engines such as battering rams and catapults, which could be mounted on wheeled platforms. These machines enabled armies to breach fortified defenses more effectively, leading to changes in military tactics and siege warfare. 4. Logistics and supply lines. The use of wheeled vehicles allowed for the establishment of efficient supply lines, enabling armies to maintain a steady flow of provisions, reinforcements, and equipment to the front lines. This contributed to the sustainability and effectiveness of military operations. 5. Cavalry and horse-drawn warfare. The invention of the wheel allowed for the development of horse-drawn chariots and later mounted cavalry. The use of chariots and cavalry units provided armies with increased speed, maneuverability, and shock power on the battlefield. 6. Tactical flexibility. The mobility provided by wheeled vehicles allowed for greater tactical flexibility and the ability to respond rapidly to changing battlefield conditions. Armies could reposition their forces more quickly, exploit weaknesses in the enemy's lines, and engage in hit-and-run tactics. 7. Transportation of artillery. With the advent of gunpowder and artillery, wheeled vehicles became essential for the transportation of cannons and other heavy artillery pieces. This enabled armies to deliver devastating firepower against enemy positions and fortifications. The invention of the wheel transformed military strategies by offering new possibilities for mobility, logistics, and firepower. It influenced the development of new weapons, the organization of armies, and the tactics employed in warfare. The importance of wheeled vehicles in military operations continued to evolve as technology advanced, leading to the development of tanks, armored vehicles, and other mechanized warfare capabilities in modern times. While wheeled vehicles brought significant advantages to warfare, they also had several challenges and limitations. Here are some of the notable ones. 1. Terrain limitations. Wheeled vehicles are more suitable for traveling on flat and solid surfaces, such as roads or open plains. Rough or uneven terrain, Dense forests, swamps, and mountainous regions pose significant challenges to the mobility of wheeled vehicles. In such terrains, alternative means of transportation, like infantry or pack animals, were often preferred. 2. Vulnerability to obstacles and defenses. Wheeled vehicles were susceptible to obstacles and fortifications that impeded their movement. Natural barriers like rivers, ditches, and steep slopes could hinder or block the progress of wheeled vehicles. Additionally, fortifications such as trenches, walls, and obstacles like caltrops or spikes could pose significant challenges and restrict the mobility of wheeled vehicles on the battlefield. 3. Maintenance and repair. Wheeled vehicles, especially complex ones like chariots or early military wagons, required regular maintenance and repair. Wheels, axles, and other components were subject to wear and tear and needed skilled personnel and resources for upkeep. Lack of proper maintenance and repair facilities could limit the operational readiness of wheeled vehicles. 4. Dependence on suitable infrastructure. The effective use of wheeled vehicles in warfare often relied on the availability of suitable infrastructure, such as well-maintained roads or paths. In the absence of proper roads, wheeled vehicles faced difficulties in maneuvering, and their speed and efficiency could be significantly compromised. 5. Vulnerability to weather conditions. Adverse weather conditions, such as heavy rain, snow, or mud, could severely impact the mobility of wheeled vehicles. Slippery or muddy surfaces made it challenging for wheels to gain traction, resulting in reduced speed and maneuverability. This limitation could affect the ability to conduct operations effectively in certain seasons or environments. 6. Limited carrying capacity. Wheeled vehicles had inherent limitations in terms of carrying capacity. While they could transport larger loads compared to other means of transportation, there were still practical limits to the size and weight they could handle. This could restrict the number of supplies, equipment, or personnel that could be transported using wheeled vehicles. 7. Tactical vulnerability. In certain combat scenarios, wheeled vehicles could be vulnerable to specific tactics employed by the enemy. For example, chariots, although fast and maneuverable, were susceptible to attacks targeting the horses or disabling the wheels. The use of wheeled vehicles required careful consideration of these vulnerabilities and appropriate countermeasures. Despite these challenges, wheeled vehicles remained a crucial component of warfare throughout history, and technological advancements have addressed some of these limitations. For instance, the development of tracked vehicles, armored vehicles, and modern engineering capabilities has expanded the range of terrain and conditions in which wheeled or wheel-tracked hybrid vehicles can operate effectively. The limitations of wheeled vehicles in warfare had a significant impact on military strategies and tactics. Here are some ways in which these limitations influenced military approaches. 1. Terrain-based strategies. The limitations of wheeled vehicles in rugged or difficult terrain necessitated the development of strategies that focused on exploiting favorable terrain and avoiding areas unsuitable for wheeled vehicles. Military commanders had to consider the terrain's impact on mobility and adjust their plans accordingly, utilizing infantry alternative means of transportation in challenging environments. 2. Fortification and obstacle-centric tactics. The vulnerabilities of wheeled vehicles to obstacles and fortifications led to the development of tactics that heavily relied on fortifying positions and creating obstacles to impede the enemy's wheeled vehicles. Trenches, walls, and other defensive structures were strategically placed to hinder the mobility of the enemy's wheeled forces and force them into more vulnerable positions. 3. Combined arms approach. Recognizing the limitations of wheeled vehicles in certain scenarios, military strategies often incorporate a combined arms approach. This approach involved the coordination of different types of units, including infantry, cavalry, artillery, and wheeled vehicles. By combining the strengths of various units, commanders could leverage the mobility of wheeled vehicles in suitable areas while relying on other means of transportation for difficult terrains or specific tasks. 4. Emphasis on logistics. The limitations of wheeled vehicles in terms of terrain and carrying capacity necessitated a greater emphasis on logistics. Military planners had to carefully consider supply routes, availability of suitable infrastructure, and alternative means of transportation to ensure the timely delivery of supplies and reinforcements to the front lines. This required establishing robust supply lines and support infrastructure, 5. Adaptation of tactics. Military tactics were adapted to leverage the advantages and mitigate the limitations of wheeled vehicles. For example, cavalry units often utilized hit-and-run tactics, exploiting their speed and mobility to strike quickly and retreat before the enemy could respond effectively. The use of cover skirmishing and the coordination of infantry with wheeled vehicles were also employed to maximize their effectiveness on the battlefield. 6. Integration of alternative transportation. In situations where wheeled vehicles face significant limitations, military strategies incorporated alternative means of transportation. Pack animals, human porters, boats, or other non-wheeled vehicles were utilized to overcome terrain challenges, transport supplies, or support military operations in areas where wheeled vehicles were impractical or inefficient. The limitations of wheeled vehicles in warfare necessitated flexibility, adaptability, and a comprehensive understanding of the operational environment. Military strategists and commanders had to carefully consider the capabilities and limitations of wheeled vehicles when formulating their plans, adjusting tactics accordingly to optimize their effectiveness while mitigating vulnerabilities. Here are a few examples of specific military tactics that were adapted to leverage the advantages of wheeled vehicles. 1. Flanking maneuvers. The speed and maneuverability of wheeled vehicles, such as chariots or later cavalry units, allowed for effective flanking maneuvers. By exploiting the mobility of wheeled vehicles, commanders could quickly move around the enemy's flanks, attacking from unexpected directions and disrupting their formations. Flanking maneuvers aim to encircle the enemy, cut off their retreat, or attack their vulnerable rear areas. 2. Hit-and-run tactics. Wheeled vehicles, particularly cavalry units, were well suited for hit-and-run tactics. They could swiftly approach the enemy, launch a sudden attack, and then quickly disengage and retreat. This tactic aimed to disrupt the enemy's formations, create confusion, and inflict casualties while minimizing the risks of prolonged engagements or being drawn into unfavorable combat situations. 3. Raiding and harassment. The mobility of wheeled vehicles allowed for effective raiding and harassment tactics. Small, fast-moving units equipped with wheeled vehicles could conduct hit-and-run raids on enemy supply lines, communication routes, or rear areas. These raids aim to disrupt enemy logistics, demoralize their forces, and divert their attention from the main objectives. 4. Screening and reconnaissance. Wheeled vehicles were employed for scouting, screening, and reconnaissance purposes. Light and agile wheeled units could move ahead of the main force, gather information about the enemy's positions, strength, and movements, and report back to the commanding officers. This information was crucial for situational awareness, decision-making, and planning subsequent military actions. 5. Cavalry charges. The speed and shock power of wheeled vehicles, particularly cavalry charges, were utilized as a tactical advantage. Charging at high speeds, cavalry units mounted on wheeled vehicles could break through enemy lines, disrupt formations, and create chaos among the enemy ranks. Cavalry charges aim to exploit the psychological impact of a fast-moving and heavily armed force, often leading to the enemy's disarray and subsequent exploitation by friendly infantry forces. 6. Pursuit and exploitation. Wheeled vehicles played a vital role in pursuit and exploitation tactics. After successfully defeating the enemy or causing their retreat, wheeled units could quickly pursue and harass the retreating forces. This prevented their reorganization, inflicted additional casualties, and disrupted their ability to regroup effectively. Wheeled units also aided in exploiting the gains made by the main force, rapidly advancing into enemy territory and seizing strategic objectives. These are just a few examples of tactics that were adapted to leverage the advantages of wheeled vehicles in warfare. The specific tactics employed varied across different historical periods, cultures, and technological advancements, but the underlying principle was to maximize the mobility, speed, and shock power afforded by wheeled vehicles to gain a tactical edge on the battlefield. In addition to mobility and speed, wheeled vehicles provided several other advantages in warfare. Here are some notable ones. 1. Increased carrying capacity. Wheeled vehicles allowed for the transportation of larger loads compared to other means of transportation available at the time. They could carry heavier weapons, supplies, and equipment, enabling armies to project their power over greater distances and sustain operations for longer periods. This enhanced carrying capacity contributed to the logistical capabilities of armies and their ability to support extended military campaigns. 2. Efficient supply and logistics. Wheeled vehicles facilitated the establishment of efficient supply lines and logistics networks. They enabled the rapid movement of supplies, ammunition, and provisions to the front lines, ensuring that armies were adequately equipped and sustained during operations. Wheeled vehicles helped streamline the logistical operations of militaries, improving their responsiveness and reducing dependence on manual labor or slower modes of transportation. 3. Psychological impact. The sight of wheeled vehicles, such as chariots or later armored vehicles, on the battlefield had a significant psychological impact on both friendly and enemy forces. Wheeled vehicles represented technological superiority, power, and a formidable force. Their presence often instilled fear, intimidation, and demoralization in enemy ranks while boosting the morale and confidence of the troops operating the wheeled vehicles. 4. Platform for weapon systems. Wheeled vehicles served as platforms for various weapon systems, enhancing the firepower available to armies. For example, chariots were equipped with spears, bows, or blades, while later wheeled vehicles carried cannons, machine guns, or rocket launchers. The integration of weapons on wheeled platforms increased the offensive and defensive capabilities of armies, allowing for the delivery of devastating firepower against enemy positions. 5. Command and control. Wheeled vehicles provided a means of rapid command and control on the battlefield. Commanders could use wheeled vehicles to move swiftly between different sections of the battlefield, assess the situation, and issue orders in a timely manner. This facilitated better coordination, decision-making, and the ability to respond quickly to changing circumstances during military operations. 6. Symbol of prestige. Wheeled vehicles, particularly chariots in ancient times, became symbols of prestige and status for military leaders. The possession and effective use of wheeled vehicles demonstrated the wealth, power, and sophistication of a particular army or civilization. They served as a visible representation of military might and technological advancement, influencing the perception of strength among allies and adversaries alike. These advantages collectively contributed to the evolution of warfare, enabling armies to operate with greater efficiency, firepower, and strategic reach. Wheeled vehicles played a crucial role in shaping military operations throughout history and paved the way for further advancements in mechanized warfare. There were several disadvantages and limitations associated with the use of wheeled vehicles in warfare. Here are some notable ones. 1. Terrain limitations. Wheeled vehicles were less effective in rough, uneven, or difficult terrain such as forests, swamps, mountains, or dense urban areas. Their mobility was significantly hindered in such environments, limiting their operational effectiveness and requiring alternative means of transportation or infantry support. 2. Vulnerability to obstacles and fortifications. Wheeled vehicles were susceptible to obstacles and fortifications that impeded their movement. Natural barriers like rivers, ditches, and steep slopes could pose challenges, while fortifications such as trenches, walls, or obstacles like caltrops or spikes could restrict their mobility or render them immobile. 3. Maintenance and repair. Wheeled vehicles require regular maintenance and repair. Wheels, axles, and other components were subject to wear and tear and needed skilled personnel and resources for upkeep. Lack of proper maintenance and repair facilities could limit the operational readiness of wheeled vehicles, rendering them unreliable or inoperable. 4. Dependence on suitable infrastructure. The effective use of wheeled vehicles relied on the availability of suitable infrastructure, such as well-maintained roads or paths. In the absence of proper roads, wheeled vehicles faced difficulties in maneuvering, and their speed and efficiency could be significantly compromised. This dependence on infrastructure restricted their operational flexibility and limited their use to areas with adequate road networks. 5. Vulnerability to weather conditions. Adverse weather conditions such as heavy rain, snow, or muddy terrain could severely impact the mobility of wheeled vehicles. Slippery or muddy surfaces made it challenging for wheels to gain traction, resulting in reduced speed, maneuverability, and even immobilization. Extreme weather conditions could render wheeled vehicles ineffective or require additional resources and efforts to maintain their operational readiness. 6. Limited protection wheeled vehicles generally offer limited protection to the occupants compared to more heavily armored vehicles. They were susceptible to small arms fire artillery or explosive devices, making them vulnerable on the battlefield. This vulnerability necessitated the development of tactics and strategies to mitigate risks and exploit their mobility while minimizing exposure to enemy fire. 7. Limited carrying capacity. Despite their increased carrying capacity compared to other means of transportation, wheeled vehicles still had practical limits to the size and weight they could handle. This limited the number of supplies, equipment, or personnel that could be transported using wheeled vehicles. In certain situations, the need for a larger carrying capacity necessitated the use of alternative transportation methods. Despite these limitations, wheeled vehicles have played a crucial role in warfare throughout history. Technological advancements and the development of hybrid wheel-tracked vehicles have addressed some of these limitations, expanding the range of terrains and conditions in which wheeled vehicles can operate effectively. The bicycle was invented in the early 19th century, with the first verifiable claim for a practical bicycle design made by the German Baron Karl von Drais in 1817. Drais' design, known as the Draisine or Laufmaschine, was a two-wheeled vehicle propelled by the rider pushing their feet against the ground. However, it was not until the 1860s that the modern bicycle design with pedals and a chain drive system was developed. The French engineer Pierre Micaux and his son Ernest Micaux are credited with developing the first practical pedal-driven bicycle, known as the bone shaker or velocipede. This design featured a wooden frame, iron-rimmed wheels, and pedals attached to the front wheel. Throughout the late 19th century, bicycle designs continued to evolve, with improvements in materials, gearing systems, and safety features. The introduction of the pneumatic tire in the 1880s significantly improved comfort and ride quality. The bicycle gained popularity as a means of personal transportation, recreation, and sport. It became an important mode of transportation for individuals, and its affordability and ease of use contributed to its widespread adoption. In the context of warfare, bicycles were first used as a practical means of transportation by the military in the late 19th century. They offered advantages such as speed, maneuverability, and reduced dependence on animal transport. Bicycles were used for reconnaissance, messenger duties, and transportation of supplies in various conflicts, including the Franco-Prussian War and World War I. The bicycle's military use declined with the advent of motorized vehicles and more advanced transportation technologies. However, bicycles continue to be used in certain military contexts today, such as by special forces or in situations where their advantages in mobility, stealth, and low logistical requirements are valued. Overall, the invention and development of the bicycle had a significant impact on personal transportation, recreation, and military logistics, providing an efficient and accessible mode of transportation for various purposes. During the late 19th century, there were several significant improvements in bicycle design that contributed to the evolution of the modern bicycle. Here are some notable advancements. 1. Pedal-driven design. The introduction of pedals and a chain drive system was a significant improvement in bicycle design. This innovation allowed riders to propel the bicycle forward by pedaling, instead of relying on pushing with their feet as in earlier designs like the Draisine. The pedal-driven design greatly increased the efficiency and ease of riding. 2. Safety bicycle. The safety bicycle design, introduced in the 1880s, represented a major leap forward in terms of comfort, stability, and safety compared to earlier designs. The safety bicycle featured two equal-sized wheels, a diamond-shaped frame, and a chain-driven rear wheel. This design allowed for a lower center of gravity, better weight distribution, and improved control, making it more accessible and practical for everyday use. 3. Pneumatic tires. The invention of the pneumatic tire by John Boyd Dunlop in 1888 revolutionized bicycle comfort and ride quality. Pneumatic tires, filled with air, provided a cushioning effect that absorbed shocks and vibrations from the road surface. This made riding smoother, reduced fatigue, and improved traction, especially on uneven or rough terrain. 4. Tubular steel frames. The use of tubular steel frames replaced earlier designs that utilized wooden frames or iron tubing. Tubular steel frames were lighter, stronger, and more durable, providing a better balance between weight and structural integrity. This advancement in frame construction contributed to increased stability, reliability, and longevity of bicycles. 5. Gearing systems. The development of more advanced gearing systems allowed riders to adjust the gear ratio to match their riding conditions and preferences. The addition of gears, such as the invention of the derailleur system by Paul de Vivie in the late 19th century, provided options for easier pedaling on inclines or for achieving higher speeds on flat terrain. 6. Ball bearings. The use of ball bearings in the bicycle's hubs, bottom brackets, and headset improved the smoothness and efficiency of rotation. Ball bearings reduced friction, allowing for easier pedaling, smoother handling, and increased durability of moving parts. These improvements in bicycle design during the late 19th century transformed the bicycle into a more practical, comfortable, and efficient mode of transportation. The safety bicycle with pneumatic tires, pedal-driven mechanism, and other advancements became the foundation for subsequent bicycle designs, and many of these features are still present in modern bicycles today. After the bicycle, several significant vehicle inventions followed, each contributing to the ongoing evolution of transportation. Here are some notable examples. 1. Motorized bicycle. The next major development was the motorized bicycle, also known as the motorbike or motorcycle. In the late 19th century and early 20th century, inventors started attaching small internal combustion engines to bicycles, creating motorcycles. These motorized bicycles offered enhanced speed and range compared to traditional bicycles and laid the foundation for the development of motorcycles as a separate mode of transportation. 2. Automobile. The invention of the automobile or motorcar was a groundbreaking advancement in transportation. Carl Benz is widely credited with creating the first practical automobile powered by an internal combustion engine in 1886. The automobile revolutionized personal transportation by providing a self-propelled vehicle capable of carrying passengers and goods over longer distances at higher speeds. The subsequent advancements in automobile design, including mass production methods, improved engines, and safety features, led to the widespread adoption of automobiles as the primary mode of transportation in many parts of the world. 3. Airplane. The invention of the airplane by the Wright brothers, Orville and Wilbur Wright, in 1903 marked a monumental achievement in human history. The airplane enabled human flight and opened up entirely new possibilities for long-distance travel and transportation. The development of aviation technology led to the creation of commercial airlines, military aircraft, and other aviation-related industries, transforming global connectivity and transportation. 4. Tractor. The tractor revolutionized agricultural practices by replacing animal-powered machinery. Tractors were developed in the late 19th and early 20th centuries and provided more efficient means of plowing fields, hauling loads, and powering other farm implements. Tractors not only increased productivity but also reduced the dependence on manual labor and animal power, leading to significant advancements in agriculture. 5. Electric vehicles. Electric vehicles (EVs) have a long history, with early experiments and prototypes dating back to the 19th century. However, recent advancements in battery technology and environmental concerns have led to a resurgence of interest in electric vehicles. Modern electric cars, such as those powered by lithium-ion batteries, offer an alternative to traditional internal combustion engines, providing a cleaner and more sustainable mode of transportation. These are just a few examples of the vehicle inventions that followed the bicycle. The ongoing advancements in transportation continue to shape the way we travel and move goods. With ongoing developments in electric and autonomous vehicles, hyperloop technology, and other innovative transportation solutions,